Hey guys, welcome to Code Decode. In this video, we are going to look into some AWS interview questions which for the basic level, that is for 2 to 3 years experience people. So these are going to be some basic interview questions and then we are going to move to higher level. So let's get started and see what is AWS. So everywhere you find that AWS is a cloud computing platform. So what does these three words means? Cloud means it's a network of servers, the data storage or the databases and services accessible over internet rather than being at your local system. So here you can see there are multiple servers connected with each other, and each server might have multiple databases connected to each other, and the combination of all these things which is available on the internet to you becomes the cloud. So what happens is when you run your Java application, you will be needing a server. So you run it on your machine, on your system, on your laptop, that is a server. When you have to deploy and you have thousands of customers around, you might need to replicate it at multiple servers. So what you will do, will you go to market, purchase 10 computers, duplicate your application to 10 servers and then make it available to client for the better latency and better load balancing? That can be done if you have a very sensitive application, and that becomes your private cloud that you set up in your own home or office. But when it comes to cloud, it's far more easier because there is no upfront cost. There you have to go to market, purchase every server, everything database has to be managed by you, everything has to be done by you. You are responsible if the server is going down, if your database is needing maintenance, everything you have to do. So rather how nowadays things have changed is that cloud comes into picture. Like AWS people, what they have done is they have created their own data centers. What are data centers? There are the set of servers, and all those set of servers will have proper computing process. You can ask the AWS, please rent me one of your server. I want to run my application to it. And when the sale comes, I want more of your servers. Now AWS people says, oh, we have many servers. You can take as much as you want. Just pay for each compute resource you take. So if you take a server, pay for it. If you also use a database, pay for it. So what they do is they provide you everything as a renting property. So you don't have to go to market and purchase your computers and laptops. What you can do is you can rather go to AWS and say, today I need one server, I'm going to pay you 100 rupees. Now tomorrow I want to have 10 more servers because sale is going on for my application. I want 10 more servers. So I'll be paying 10 into 100 rupees. Only for that day. As soon as my sale ends, I am going to reduce my server requirement again to 1. That you cannot do with your own physical server. So that's why cloud is such a hype nowadays, because it's a pay-as-you-go model. You rent your computer from AWS rather than purchasing at your own. So that is why AWS and Azure and GPC are nowadays on hyped, because they let you rent it. That lets you save your money. And it will also do all the kind of maintenance and issue fixing if there is something in their hardware. Otherwise, if it would have been yours, you would have to do it. So cloud is just a network of servers and data storage and services, everything that you have on your local also, but it is provided over internet. So here is my console for AWS. Here what they do is they provide you all these services. They provide you EC2 instance, S3, RDS, everything they provide. Just that they will be charging you only for the time you use. So suppose I want to test my application on cloud, I can create my EC2 instance, deploy my application there, test it, delete my EC2 instance, and I will be paying only for the time I actually run my application and I use that EC2 instance. If AWS would not have been there, I would have to go to a proper shop, get a proper system, create a server out of it, run my application there, and done. Test it. But if there is no use after it, then it's a waste. There's upfront cost that is gone. So it's always said that when you want to rent a computer or a compute thing, you can go to AWS. Not only just the servers and data storage they do, they also provide you services. And services, for example, Kubernetes service they provide. Many services will be seeing down in the upcoming questions. Many services are available to you to use. So this is how the cloud is created, with a network of servers. Now what is computing? Computing means processing and managing your information using computers. What does that mean? That means I want to run an application. What I need hardware, I need software, I need CPU, I need multiple things, right? All those things can be done with a computer. Now, what does the computer do? It does the computing for you. So the task including running your application, storing and retrieving data from the database, performing multiple calculations are known as computing. So cloud computing is a network of servers involving multiple data stores, services, who all together can perform and process and manage your information in computers, which is over the internet and not at your home. So that's cloud computing. A platform is just an environment. So if you can see here, this is the dashboard provided by AWS to you. They also provide you CLI. So all these things together create a platform where you can use all these services and all these compute things, like for example a server or the S3 bucket. So that's the meaning of cloud computing platform. Now coming back to what is AWS. So AWS is Amazon Web Services. You can think it as a big collection of computer servers, the data stores, these services, and they are connected to the internet and hosted by Amazon for you. So if you can see here, who hosts this or everything is hosted by Amazon for you. So now imagine you have a big business and you need a place to store all your data and files. So instead of buying your own servers and set them up in your own room, you can ask AWS to rent you. So it's like renting a space in a huge data center where you can store all your information and use that computing services given by their computer to you. So you don't have to go to market, you don't have to purchase your service, you just ask AWS, lend me one. I'll pay for the time I use. After that, you can give the same server to some other person who would be in need of it. The AWS provides different types of services also. For example, it provides you S3. S3 is a storage service which is like a big virtual storage room where you can dump all your data of your application would need. Otherwise, what you would have done, you would have went to market, you would have purchased the hard disk, the drives, you would have the external hard disk where you can store your data. Rather than doing all those things, you can just go to S3 and store your data there, dump it there. So if you are building a website or an application, you can use EC2 instance, which is like renting a computer on cloud that runs your application. So you don't have to purchase a server. Rather, you can just rent that particular computer or the server from the Amazon and create an EC2 instance and deploy your application on your EC2 instance. AWS also offers other useful services like databases, the machine learning tools, and even the capability to analyze the big data. It's like having a toolbox filled with different tools that can help you run your business more efficiently. Otherwise, if they won't provide you these services, you would need a DBA, the database administrator, to manage your databases locally. You would need a proper data analytic person to analyze your big data. All those services, since are already provided by AWS, you don't need to hire them. Rather, you can just use services given by AWS to you. So one of the best thing about AWS is it's flexible. You can use as much or as little as you need. If your business grows, you need more storage or compute, or you need more servers, you can easily scale up by renting more. And when your task is done, leave that. So that's how they are very flexible. If the sale is going on your application, you need more compute resources, you need more servers, ask them, they will give you. When you are done, remove the extra servers, and that's how you pay only for what you use. So overall, AWS is a cloud computing platform provided by Amazon that provides wide range of services to help your data to be stored, to run your application, to access various tools, to have the resources over internet without having to own and maintain your own physical server in your own data center. So it's very easy. If your server fails, you don't have to think about it. There is a backup already created by AWS in some other zone also for you, and you will be good to go with the another server, and that server will sooner or later be up and running and can be given to you. Or if you already have your own server in some another zone, this server will be lent out to some another person. So your server failure is not your headache, it's AWS headache. Hey guys, recently we have launched a course covering an end-to-end full-stack application using Angular as front-end and microservices and Spring Boot as the back-end. Also, we have used Cloud to deploy this application, and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST web services, Spring Boot and microservices for back-end, Angular for front-end. GitHub we have used for
version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So, this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links.
Now, what comes as a key components of AWS? So AWS comes with multiple services. The very first service is EC2 instance. It's Elastic Compute Cloud. Means this is a web service. What does the web service means? A service which is provided over the internet. So can you create an EC2 instance from here? By hitting your URL. This is over the internet. I can create my own EC2 instance. Since you are able to create your EC2 instance with the internet, with the help of internet, you just click a create instance and a proper computer will be allocated to you for this particular account code decode. That means you're able to create and rent a whole machine over the internet. That means it is a web service because it is available over the web. You don't have to go to any office and say, AWS guys, please rent me this. No, you don't have to do. You just sit at your home, try to access your EC2 and S3 with your internet and you are able to do that. That is a web service. So this is a web service that provides virtual servers, also known as instances in the cloud. It allows you to easily create and manage your virtual machines to run your application or host your website. So there will be a server. Now, if you need a very small virtual machine, what you do is either on your system, you provide a VDI and create your own virtual machine. Rather than doing it on your own system and having the tension that are my configurations good? Is my setup complete? I have to manage if my VDI dies or crashes. Leave everything to AWS people. Go to AWS and ask that you need an EC2 instance. It will create a virtual machine on their server and will give it to you. If anything happens to their hardware, it is their headache. But anything happens to your virtual machine, it is your headache. Remember that. So EC2 is just to create a virtual machine or rent a computer or a part of computer over the internet. That is the EC2 instance web service provided by AWS to you. Next is S3, that is a simple storage service where you can store and retrieve your data such as files, images, videos over the internet. If it would not have been there, what you would have done? You would have gone to market, purchased a external hard drive, add everything, image, video there, then you plug it in your system and see whenever you need it. How easy is it that you go to internet, you just open your console dashboard, you go to S3, create a bucket, add your objects to that bucket and access it over the internet. How simple is that? So this is a scalable storage service provided over the internet to have your data stored over the internet, so that not just if you don't have your hard disk, if you go to some other place, your friend's place, you don't have hard disk, you don't have access to your photos and videos because your photos and videos would have been in some external hard disk which is kept at your own home location. So rather to have it on internet, you can access it anywhere, be it your home, be it your friend's home, anywhere. So that's the advantage of S3 service provided by AWS to you. It provides you high durability, availability and security for your storage objects also, because you will have images and everything. You need security also. So AWS S3 is always encrypted. You can always encrypt your data while storing it in your bucket. Then we have Amazon RDS, that is a relational database service which is managed by AWS itself. So RDS is a managed database service. What does that mean? Managed database service means anything goes wrong with the hardware of the database, you are not responsible for it. The continuous maintenance of database, everything will be done by AWS people for you. You don't have to do it. So it simplifies the setup, operation, and scaling of the relational database such as MySQL, Postgres, Oracle, or SQL Server. So all the administrative tasks such as taking the backup of it, software patching, and everything will be done by AWS people, and you are allowed to just focus on your application and get and retrieve the data from that particular database. You don't have to think about how the database hardware is backed up, how it is patched. Everything will be done by AWS people for you. The fourth is Virtual Private Cloud, VPC. It allows you to create a private network within the AWS cloud. So what happens is, I have 10 applications and these 10 applications needs 10 different servers to run. So what I'll do is, I'll take 10 servers from them and I'll pay 100 rupees for each server. That is fine. But since these servers are publicly available, my data can be vulnerable to attack. So what I can do is, I can create my private cloud and connect all those private servers with a virtual private network. And thus it provides isolation and security of your resources and enables you to define the subnet routing, control access using the security groups and network security. So this allows you to have a very fine control over all the servers you have that will not be available to any public people because they are all connected with a private network. What is IAM? This is another service given by AWS to you. It is a service that helps you manage the access to AWS resource securely. It's like an identity and access management. It's a security that is given to your AWS resource, and thus it allows you to create and manage your users. So suppose you have a server and you have 10 employees working under you. So you can create 10 roles or 10 users and group them based on your upper management, senior developers, junior developers, give them groups accordingly, and according to group and their role you can grant the access. So to delete a server, to delete a database, only the higher level management can do. To create a database, senior database can do. And to update the data, only and only update and retrieve the data, the junior developers can do. So this is how you can group based on roles all your users and have a fine-grained control to all the resources and what they can do on those resources. That can be done with IAM, which is very important service, because as your application grows, your employee strength can grow, and hence your security is the first thing. That because if the junior developer is given a task to delete the whole database, your whole data is gone. Even if you have a good database backup, still you would need some time to retrieve and update your data, and your production environment will be down. Thus, IAM is a very important service given by AWS to you, and whenever you work in a real-time environment, you will always have IAM in place whenever the AWS is used as your deployment place. Next is Lambda. Lambda is a serverless computing service that enables you to run your code without managing the servers at all. In what happens in EC2, you have to have your server. You have to own a server's virtual machine. So anything goes wrong with the virtual machine, it's your problem. Lambda is a serverless computing. You won't have any virtual machine or the server. You can just upload your code. Lambda will automatically create the virtual machine, handle every infrastructure, scale it based on incoming request. Your task is completely gone. So that's the beauty of serverless computing, when you don't need to manage anything. Everything will be done by AWS automatically. You just provide your code to AWS. AWS is smart enough to create the infrastructure, scale it if the incoming request increases, and scale down whenever the request goes down. So that's Lambda, that is serverless computing. Next is SNS, that is simple notification service. So if you have an e-commerce website, whenever order is placed successfully, you send a message and a notification, your order is placed successfully, expect your delivery by this time. So AWS also provides you this service. You don't have to create your own SendGrid, you don't have to create your own Spring emailing service, don't do that. Rather, just call this SNS messaging services that allows you to send notification messages to your clients, and it supports various delivery protocols, including they can send email for you on your behalf, they can send SMS also, they can send push notifications. Everything that you can do with your own code, that can also be done with this service. So this also reduces your headache for managing a complete separate microservice for emailing. What you can do is directly integrate with this particular AWS service and you're good to go. CloudWatch. You deploy your application to production. Now what happens if your production is down? What happens if production is having continuous errors? What happens if your performance is very bad at production and your clients are facing issues with the performance? So continuous monitoring and observability and insight into your AWS resources and application will be given by CloudWatch to you. So it will track, it will collect and track all the metrics, it will monitor your logs, it will set alarms and trigger you whenever there is some continuous exception coming, like there are multiple null pointer exceptions coming. So it will trigger you, it will mail you, it will have alarms with him, it will notify you that your application is down on the production, your clients are affected, please go and check it. So it also generates visualizations too for you to monitor and troubleshoot your infrastructure issue. Even if your server crashes, your application is down. So who checks whether your server is up? What is the health situation? Everything that is required for monitoring and observability will be done by CloudWatch for you. What is EC2? So EC2 is Elastic Cloud Compute. As I already told you, it is a part of the server which is given to you as a virtual machine for your own benefit, where you can run everything as you can run on your own laptop or your own PC. The similar thing you can do on your rented virtual machine created somewhere in another part of world in AWS data center. You can just lend that and run everything like you do in your own computer. Just rent it from AWS and you're good to go. So that is a service which is provided over the internet by AWS to let you rent a virtual computer in their data center, where they have thousands of servers available open for you. So it is not a physical machine that you can touch. It is not your system or your PC. It's just a powerful computer that exists somewhere in the world, in their cloud, in their center. It can be anywhere. It can be in USA also. So here, if you can see, I have multiple areas and regions where I can create my resources. I can create in Singapore, Tokyo, Mumbai, anywhere I can create my resources. But remember, if you create it near to your own country, it will be low latency and low cost. Otherwise, if you create a very long distance, then your performance will be affected, because data takes time to reach from one place to another, and this is a complete different set of country from where data is coming. So latency will be bad, your cost will be high, and everything will be affected if you do not create your instances and resources nearby. So EC2, you can use this virtual computer to run your software and website. You do not need computer related tasks without needing to own and maintain a physical server. So you can do everything and anything you do on your system just like you're doing it on your cloud. So it's like having a computer that you can turn on and turn off whenever you need, but you pay only when you use it. Also, you don't have to purchase it. So it's pay as you go model. Use it, pay for it. So EC2 is basically a fundamental service for building and running your application in the cloud. Now, what is the pricing model for EC2 instance? There are 4 types of pricing models for EC2 instances. Now you have 1,000 servers there in the data center. Suppose there are always more than that for sure. But suppose there are 1,000 servers in that data center. Now you want to have one of these servers for your use. So what you can do is, you can have 4 types of allocation of those resources. First is on-demand instance. Okay, today I need that instance for 2 hours for testing of my application. So what you do is, you go to the AWS, you create your EC2 instance, and on demand you are rented a computer on the go. So what you can do is, you can quickly get a virtual server whenever you need it and just pay for the hours and seconds you use. For imagine needing a computer for a few hours to test your website. So on demand lets you grab one instantly and you only pay for the time you use. That's okay. When the application is very small, you need it, you test it and you delete it. That is on demand instance. But when your application grows, what you do is, you get a subscription for that specific type of computer. So what you say is, I am going to commit that my application is going to be on live and on production for 3 years. So for 3 years, I am going to use your computer. I'm going to rent your computer from your data center. And so AWS will ask you to pay the upfront cost and you get a big discount. Why? Because on demand customers are like, when they need it, AWS provide them. Other time their servers are idle, they are of no use, there is no pricing that they get after the EC2 instance is terminated. But when it comes to your reserved instances, you reserve that particular server for 3 years and you pay the cost, like for 3 years, for the 100 rupees per day I'm going to pay this much amount. So they will provide you discount, that because they also are benefited out of the reserved instances. Why? Because they know that even if you are having a downtime, your application is not on your cloud, still AWS will get the money for it, because they have already taken the money for 3 years for your particular reserved instance. So if you need a reliable computer for a long project, you reserve it. You pay less and it's always available when you need it, which will not be the case on on-demand instance. So suppose all the instances are full, AWS cannot provide you in that particular zone or region, then you will not get that instance. But it is bad when you have a real-time application working with multiple clients and multiple clients using them. So at that time, it's better to reserve your instance so that it is always available for you and nobody else can take it up, or there won't be any situation that your data center is full. There is another interesting way of pricing, that is spot instances. Now suppose I want to test multiple applications multiple time a day, but only for a small time. So what they do is, these people, the AWS people, have a bidding system. So suppose there are thousands of computers, out of 1000, only 10 computers are reserved. So for that they can't touch it. They have some allocated to on-demand customers, but they know that still their 500 computers are completely empty and of no use, but they are up and running. Their unused computers they put for bidding and say, okay, take it for only 50 rupees. So what you do is, you bid for extra computers. You bid, say, okay, I'll put 60 rupees for each computer and I'll take 5 computers of yours. So you bid for unused computers. If your bid is higher than the current price, that is, you bid for 60 rupees and the current price they are giving is 50 rupees, you get those computers at a very big discount. Otherwise, you would have to pay 100 rupees, even it is on demand instance or if it is a reserved instance. So spot instances are very beneficial when you know that you would need it for a very less time. And if there are some extra computers remaining, give it to me, I'll just use it and give it back. So when will you use the spot instances? You're okay with using extra computers that are available at a high discount rate. You bid for them, and if your bid is highest, you get those computers until someone else bid higher or the price goes up. So this is very important, and this is the biggest disadvantage of spot instances. You bid 60 rupees, but later on some other person comes and says, I'm going to pay you 70 rupees, give all the spot instances to me. So your instances then and there will be terminated and will be given to the guy who is bidding higher. So all your data will be lost, your instance will be lost, and your testing might be stopped in between. So this is the biggest disadvantage of spot instances. For sure, you will get a very good discounted price for the unused computers that are already in the AWS data center. But anybody can snatch it from you if they pay better to AWS people than you. So that is the third pricing you can have, and also they can have a dedicated host. This is a very, very costly thing. What they do is, it's similar to you have your own personal computer in the cloud. You get a complete physical computer just for yourself, and no other virtual machine can be even created if that particular server is with you. So then this way you have more control over your server. So if you have specific rules and you need to keep your stuff completely separate from others, you get the whole computer just for you, just like having your own private space in the cloud. Now suppose for my application, I just need 4 GB of RAM, 2 cores of CPU. It's very simple configuration I need. The servers are like 16 GB RAM, 2 terabytes of hard disk, and a very high configuration. What they do is, they can create 4 virtual machines out of the same server, and if I need only 2 servers, the 2 servers will be given to me and 2 servers will be allocated to some other user. But the problem here is, the underlying server is common. So anybody can hack anything from my virtual machine because underlying hardware is the common one. So there is no privacy when it comes to public cloud. So if you want the privacy, you can have a complete dedicated host, but you have to pay for it. Now what is AMI? AMI stands for Amazon Machine Image. It is a virtual image used to create a virtual machine within an EC2 instance. Now when you create an instance, you have an option to create from a template. This template is an image. That image can be created from an existing EC2 instance. Now suppose I have an EC2 instance in the cloud. Now I want to scale up and have 3 more servers, but with the same configuration, everything should be same. Otherwise my instance might not run that perfectly fine. So what I'll do is I'll create the image out of the running instance and give that image to all the other EC2 instances to be created in future, so that all the instances will be created with the same configuration. So that image or the machine image is called as AMI. So an Amazon Machine Image in an EC2 is like a snapshot of the virtual server. It includes all the information about the operating system, application and configuration. So you can use AMI to create and launch new instances in the cloud with the same setup as the original instance, and it is a best and convenient way to replicate a pre-shared and pre-configured environment. So this way all your instances will be having the exactly same operating system, the exactly same application and configurations, so that every application runs in the same way as it is running right now, even when you scale it up with 3 more instances. So that's how you can have the AMIs. So currently if you launch an instance, it will ask you the image. These are the images, the Mac image, Ubuntu image, any kind of image you can use. These AMIs are provided by AWS to you. Also, if you don't want them, you can create from your own template also. Don't use it from the AWS given AMIs. First, what you can do is you can create from an existing AMI, do all the configurations, management and deploy your application and do everything that you want to do, customize it. Then from the running instance, create an AMI. That AMI will go into your AMIs here in the AMIs that you have created, and using that AMI, next time whenever you go to create an EC2 instance, you can use that image to kickstart that instance. Now next question, can an AMI be shared? Yes, AMIs should be shared. Otherwise, if I am on this particular account is creating an instance, now my colleague also wants to create an instance similar to my instance, then I should be able to share that AMI with him. So how would you do that? So identify the AMIs you want to share. So here you have multiple AMIs. You can select which AMI you want to share, modify the permission and update the permission to make it shareable. You can modify these permission through the console or also through command line. You can easily do it with the console also. And then you provide the AWS account IDs with whom you want to share the AMI. So suppose my 5 team members want to share my AMI and create the similar instances on their account. Then you can add all the 5 account IDs as the permission to be allowed to share, and once they do that, they have to accept the sharing invitation. So all the 5 person have to accept my invitation that I want to share my AMI with their AWS account. And once the owner of that account is accepting that invitation, they can easily use that AMI as their own private AMI and create the instances using that as a template. Once you have make it shareable, this image will also be visible in their account. And while creating an instance, they can create an instance using the template from the AMIs they have. Are the AMIs created automatically? Answer is no. If you want to create them, you have to manually create them. So once you launch an instances, at that time AMI is not created. You create your instance, you do every configuration, customization and everything. At the end, you can, once you want to share it or you want to have the AMI, you can create the AMI out of it. So when you launch an EC2 instances, you are using a pre-existing or pre-configured image by AWS. So here if you launch an instance, the next thing you do is you take something as a pre-configured AMI given by AWS to you. Once your EC2 instance is created, the AMI is not created automatically as soon as you launch it. What you want to do is you have to create your own manually. So if you want to capture the current state, the operating system, the application configuration of the currently running or stopped EC2 instance, you have to manually create a private AMI from that instance. and that private AMI is stored in your AWS account and can be used to launch new instances with the same setup in your own account also, and also you can share them to other people, and in some another account also you can create the instance with your private AMI once you make them shareable. Now what is elastic IP? You can see for the EC2 you have elastic IPs. So whenever you create an EC2 instances, there is a pool of IP address allowed for that particular EC2 instance. Whenever your EC2 instance is stopped and when it comes up again, a new IP address is assigned. That is a dynamic IP address is assigned. So every time are you going to change your IP address of your application? You can't do that, right? So elastic IP address is a service which is provided by EC2 instance. It is basically a static IP address attached to EC2 instance. This address is associated with your AWS account and not with the EC2 instance, because whenever you stop your EC2 instance, you start the EC2 instance again, a new IP address is there. So that is a dynamic IP address which changes again and again. So how about having a static IP address attached to your account and not to your EC2 instance, so that at any point of time, even if it stops or crashes, it comes back again, the IP address should not change, because that IP address is attached to your account and not to your EC2 instances, which keeps on coming up and down. So suppose there is a website called XYZ which is pointing to some instance that has public IP address. Now when that instance is restarted, the AWS takes another dynamic IP address from the pool of the IP address it has, and the previous IP address is no longer valid. So your xyz.com won't work. Due to this reason, the original link is no longer available. To overcome such situation, there is an elastic IP or the static IP available, which does not change with the change in EC2 instance because it is attached to your account. You can also disassociate your elastic IP address from your EC2 instance and map to another EC2 instance in your AWS account. Why can you do that? Because there is only a limited amount of elastic IPs you can create. So suppose your instance does not need a static IP. You can disassociate from that particular instance and give it to some another EC2 instance which needs the static IP. So how many elastic IPs you can create? We can create 5 elastic IPs which will be associated with your AWS account. So per region, per AWS account, you can create 5 IP. But for another region, you can again create the elastic IPs. So how will you create your elastic IPs? Here go to the EC2 instance, go to elastic IPs and create one. And also allocate this elastic IP address to one of your EC2 instance. Now a very important question. What is the difference between stopping and terminating an instance, EC2 instance? So you can stop an EC2 instance, and stopping an instance means shutting down the instance. So what you can do here, you go here and you do the shutdown. That is stopping your instance. And all its corresponding EBS and everything will still be running. So you will be charged for all those things. You will not be charged for instances compute, but you will be charged for all the corresponding things attached to your EC2 instance, like EBS volumes, databases, everything will be charged. So you can restart the instances as well, and your EBS will still be there, your data will still be there in the database. But what is terminating an instance? So you can also terminate the EC2 instance, and terminating means that you are removing the instances from your AWS account. And when you terminate it, it means that its corresponding EBS, its corresponding databases, everything will be removed and detached. And due to this reason, you cannot restart your EC2 instance again, and you will be in the trouble if you have done it by mistake, because there is no coming back, there is no recovery for this. Terminating means everything will be gone. Stopping means just your instances is stopped, but all the data that you have is still there. So that's the difference between stopping and terminating an instance. Now what are key pairs? So you have created your EC2 instance, right? We have always said EC2 instance is just like creating your own computer. So how will you access that computer things into your own computer? So I want to connect from my system to the EC2 instances on some another region like Mumbai or Tokyo from my sitting at my home through the internet. Can you do that? Yes, you can do that. You can connect to your EC2 instance just like any virtual machine you can connect from your system. You can also connect to that virtual machine created with AWS as an EC2 instance. So for that you need a key pairs. So EC2 instances using public key cryptography, which is used to encrypt and decrypt your login information. In the public key cryptography, the public key is used to encrypt the information, while at the server side, a private key is used to decrypt the information. Now, combination of these keys known as key pair, and it allows you to access your EC2 instance securely, making sure that you are the one who is able to log into EC2 instance and no other can do that. So key pair is like a digital key that you can use to securely access and communicate with your EC2 instance. It's a pair of key. One is kept on your computer. So private key is on my system and the public key is on the server where your EC2 is there. And this ensures the security is controlled access to your instance, allowing only those with the correct private key to connect to and manage them. So if you have the private key on your system, then only you are going to able to connect to your EC2 instance. Anybody else from their computer or laptop will not be able to do that because they do not have the private key with them. So this is how you can connect to the EC2 instances created in some other reason in the AWS data center from your own system securely. Now what is S3 and what are its use cases? So S3 stands for Simple Storage Service. You can use S3 to store and retrieve any amount of data at any point of time from anywhere because it is on the internet. So for S3, the payment model is again pay as you go. That means if you use that much storage, you pay for that much storage. So it's just like a massive digital storage service provided by AWS to you. It's actually a counterpart of you going to market and purchasing a hard disk or the external hard disk. You rather rent something from the AWS. So it's your virtual warehouse in the cloud where you can store and retrieve any amount of data accessible anywhere on the internet. That is S3 bucket for you. So there are some terminologies related to S3. What are these? Everything that is stored in the S3 is in the terms of buckets. So think of a bucket as a big folder in S3. So you want to organize your data into buckets just like you organize files into folders. So if I have a prod data, dev data and UAT data, I have 3 folders. Then here I have 3 buckets: prod bucket, dev bucket and UAT bucket. Now individual files are stored within the buckets are called as objects. So your photos, your static data will be different in all, suppose in dev, prod and UAT, then they will be saved separately in each bucket and each file that you store becomes the object. So your photos and videos and documents becomes the objects in the bucket in S3. And what are keys? Keys are the unique identifier for object within a bucket. So each object has a key similar to the file path, helping you to find and access it. So here in the S3 bucket, you have a key comma object combinations like a key value pair which is stored in the bucket, and you can always identify an object uniquely with the key. Now when do you use S3? So a question might arise, what is the use case? Why did you use S3 in your project? So S3 is used as the data backup and storage for you. You can use S3 to keep your backups of your important files and ensure that there is a proper data durability and accessibility whenever you need it. If your data crashes, you can always have the backup securely done at the S3 storage. Also, you can have the static websites hosted with S3, making it globally accessible and easily available. All the static data can be easily stored in the S3 buckets, and the access is also very easy across because it is over the internet available. Next is for archiving. Archiving is the way to preserve a long-term data with a very cost-effective storage class. So here with S3 there is a particular class which we're going to see in the next question. What are different classes for storing the data? Here you can easily archive and preserve your data for a long time and can be accessible whenever you need it in a cost-effective manner. Content distribution, it's something very similar. The content is distributed over the internet, so you can access it be at your home or be at your friend's home. If you forgot your external hard drive at home, you cannot access your digital data like images and videos anyways because it is at your home. But at your friend's home, you can do it easily over the internet if it is an S3 bucket. The data transfer is also very secured between AWS services, supporting the seamless integration with different AWS regions, while that can be a difficult case when you have it in your local places. Data analytics, a large data set can be analyzed using S3 as a data lake, supporting analytics services like Amazon Athena. you can also do some data analysis for all the data that is present in the S3. Application and software distribution, it will easily efficiently deploy and distribute application and softwares to users, and you can also store log information, making it easy to track your activities. So anything goes wrong, you can go to the S3, check your logs and see where your application has gone wrong. So these were some ways where you can use this particular S3 in your application for storing the data, logs and everything. So why S3 is so important? Because S3 is designed to provide 99.999911 durability of object over a given year. So if you are storing anything, it is going to be available to you with this much efficiency and durability and availability. This 11 nines is a very good amount of availability over the internet you can ever get with any storage available on the internet. S3 is also seamlessly scalable. So if one day I need 10 GB of data, you don't have to think about that I don't have that much amount of external hard disk. You just ask the AWS people to give you 10 GB and it will easily accommodate all your data as much as you need and even more. Security, it also supports multiple layers of security including the access control, encryption and identity management. Event and notification can also be triggered easily with the S3 as soon as there's something changes in your S3 bucket. You can easily get notified and you can have a workflow according to the changes to respond to the changes done in your S3 bucket. Now what are the storage classes available in S3? There are standard infrequent access, zone infrequent access, glacier and glacier deep archive. So total 5 types are there, where Amazon S3 standard is where there is a place where you store the data and you want that data to be accessed very frequently. So here the very frequently accessed data has to be stored in the S3 standard. So here the throughput is very high and latency is very low. So you ask for the data and 99.99% availability and 99.11 of durability is available for you. So that's where the frequency of access of data is very high. Then we have standard infrequent access data. So this has the cost lower than the frequently accessed data. So whenever there is a high frequency of access, cost is also high and latency is low. So there is inverse graph between latency and cost and frequency. So if you're frequently accessing the data from cloud, you have to pay more, but very quickly you will get the data. But if you are not very having the frequent access to data, you pay very less, but it will take really long time for your data to be there with you. So latency is very high if the cost is very less and frequently you are not accessing the data. So infrequent access is associated with lower storage cost compared to S3 standard. So here you can store the data, but you will have less of availability. So here you can see there is a difference in availability. Here the availability is 99.99%. Here the availability is only 99.9%, 90%. So 0.09% is there as the latency is high, availability is less. Then there is zone infrequent data, infrequently accessed, stored in a single availability zone for cost saving. Here even the availability reduces even more. Here it was 99.99, it was 99.90, here the availability is only 99.50. It has dramatically reduced from first two because here there is a zone infrequent data access. You do not have your data replicated in different availability zone because you don't want to pay high. So this is very cost effective way of storing your data in only one availability zone. Next is S3 Glacier. Now glaciers are always related to archivals. So this is a very long time archival with retrieval time in minutes to hours. So suppose I have my data lost completely, my application crashed. I want the data backup which is stored in the Glacier. So it will take me a long time, minutes to hours, even for 10 hours it can take for your data to reach to you as a backup. Until 10 hours your application will be done. So here usually you store your backups and archival things you might not need for a long time until something very rare condition happens. In that case you use for archival purpose the S3 Glacier. Here the retrieval time is really long and there is a deep archival which is even the rare scenarios, for that data it is stored in the deep archival. So for long term data with longer retrieval time with the lowest cost storage, so the cost for S3 deep archival is very less compared to the first one. So from starting of 1 to 5, your cost dramatically reduces, but your retrieval time dramatically increases. So that is the relationship between frequency of access, cost and latency. As the frequency of access increases, the storage cost typically increases. So if you have some data that has to be accessed very frequently, you have to have a very expensive storage class like the first one, Amazon S3 standard. But if you have a very less requirement of access, go with the Glacier or the Glacier Deep Archival. So generally the higher storage costs are associated with low latency for frequency access. The lower storage cost may comes with slighter higher latency due to retrieval time. So with this, if your data is in Glacier or Glacier Deep Archival, you can have access to your data in hours also. So be prepared, if you're storing here, you might not access your own data for hours and hours. So what is the default storage class in S3? The default storage class is standard frequently accessed, because they assume that if you are storing the data, you would be needing the data. Now how many buckets can be created with S3? By default, you can create up to 100 buckets in S3. What is the maximum and minimum size that you can store? So minimum is 0 bytes, you can have your empty bucket, and maximum size is 5 TB. We have many more things to cover, like EBS volumes, connect to EBS, what is AEFS, what is S3, how to get the data, and many things are still remaining. If you want the second part of this video, just let me know in the comment section. I'll create another video for this. Thank you.